Okay, this is section 3.2, graphs of functions. Start off, we're going to graph this guy here. Let's move this over. Let's get a graph going. Let's see. Alright, sorry about that. I had some technical difficulties. Okay, so this is the function we're going to be graphing first. I, it says that f of x is equal to the line x plus 3 if x is less than or equal to 1. So less than or equal to 1. So if I plug in 1, I get 1 plus 3 is 4. So when x is 1, y is 4. Plug that in there. And it's linear, so I'm just going to use 2 points. It says less than or equal to, so I could go with the y-intercept here. And when x is 0, it's at -3. So make an attempt to connect these guys. And it's just going to go down that way. And then it says that if x is greater than 1, 4. So when x is 1, not equal to 4, it's just going to be equal to 4. So it's going to be the line y equals 4. So there's that. So let's see, let's test some points. Let's say when x is 7. So x is greater than 1, we use 4. So when I plug in 7, the f of 7 would be 4. So 7 goes to 4, that's good. F of -1. If I say -1, it's less than or equal to 1. So -1 plus 3 is 2. And I go up to 2, and there's the point. And like I said, my line's not very straight, but it's pretty close. All right. Okay, so we're going to graph this one. It says that when, I always go for the equals first. So if x is equal to 2, we're going to use this guy. So this is going to be -2 times 2, that's -4. So when x is 2, we're down here at -4. And then it says when x is less than 2, we have the absolute value of x. So less than 2, so when x is 1, the absolute value of 1 is 1. So we get that guy. And when x is 0, we get the absolute value of 0, which is 0. And we get -1, we get this guy, and so on. So we have this graph, and I'm going to try to do this. It's going to be the V. It's going to come up there. And then it says less than 2. So when x is 2, it's this value, but I'm going to plug 2 into the absolute value. And when x is 2, I get the absolute value of 2, which is 2, but it says it can't equal 2. So I'm going to put an open circle there to show that. And then when x is greater than 2, so going this way, we have this line, and it's going to have a negative slope, so it's going to go down this way. And I'm going to pick one more point. Let's say 4. It's going to be at -8. Let's pick one that's actually on the grid here. So how about 3? So -6. So we get -6. And then it would just go like that. So this would be the graph, and remember, you might want to label your axis, and you might want to label the parts, something like that. Y equals -x, y equals absolute value of x, or f of x equals. Alright, we're doing this guy. Again, I go where it's equal. It says at 0, it's equal to 4. So there's that. It says when x is greater than 0, it's -1. So greater than 0, if I plugged in 1, I would get -1. And at 0, it's not going to include it, and it's going to go like that. Y equals -1. And then when x is less than 0, we have the line -2x minus 1. So it's going to have a slope of -2. Y-intercept is -1, which is here. And at 0, it's going to be a positive. Let's set this to 0. And it's going to be -2x is equal to 1. And x is equal to -1/2. So when x is 0, we have -1/2. Or y is 0, -1/2. So this guy here. And let's pick a value that's a little further out, like -4. So -2 times -4 minus 1. And we get a positive 8 minus 1 is going to be 7. And that's on the graph. Good. -4 is going to be up here at 7. And then we simply connect these dots. And that's going to go off that way. So looking at this graph, we should be able to go to 0 and get 4. So when I say, hey, x is 0, what is y? We got 4, and that checks out. So okay, x is 6. So that's greater than 0. So when I say x is 6, it better be -1. Y better be -1. So there's that. And we'll test one more point. We'll say -2. So -2 is less than 0, so -2 times -2 is a positive 4. 4 minus 1 is 3. So 3. And there it is. So it checks out. And again, label your axes, and put your, I would probably label this point as 0, 4. I would probably say this is the line y equals -1, and this is the line -2x minus 1, something like that. Alright, we're going to do this guy. The negative tells me that it's going to be a reflection. The parent graph looks like that. It's a V. And so this graph is going to look like this. So now that I have a general idea of what the shape is, I know that at 0 it's going to be 0. If I plug -1 in there, it's going to be, let's plug -1 in here. The absolute value of -1 is 1. I'll just do it here so we can see, because sometimes this can be confusing. So the absolute value of -1 is 1, and we need the opposite of that, so -1. So at -1, we're at -1, and then the absolute value of 1 is 1, and we need the negative of that. So when we plug 1 in, we get this, and these are just going to do this. And you can plot as many as you want, and this is going to be y is equal to the negative absolute value of x. Label my axes. There we go. Okay, so now we're going to graph this guy. This guy has a y-intercept at -2. So we have the absolute value of x, and this says we're going to shift it down 2 units. So if this is the absolute value of x, go down 2 units and draw the same thing. So this is now my vertex, and over 1 up 1, over 1 up 1, over 1 up 1, over 1 up 1. And we draw a V. Something like that. And y is equal to the absolute value of x minus 2. And label my axes. So something like that. You could plot points if you wanted to. You could go back and test, and you know, like -2 is the absolute value of -2 minus 2. Is that 0? So the absolute value of -2 is 2 minus 2, and that's 0, and 0 equals 0. So yeah, it checks out. And the other side's going to check out too. But okay, so that was graphs of functions, and now we're going to move on. Okay, B says explain why each of the following is or isn't an equation of a function. Does each function pass the vertical line test? Okay, so the first function is y equals x cubed. So that's going to look something like that. And the vertical line test means if I take my finger, and we'll just call this my finger, and I move it from left to right, so we'll call this my finger, I'm calling this a vertical line. Vertical lines run up and down. Horizontal lines run horizontal. Anyway, if I take my finger and I move it across this, we'll call this paper, move it across this piece of paper, can you see that for every x value it goes to one y value? And that's what's important. So we take the vertical line like this, and we can see that for every x value we have one y value, x value, y value, and nowhere on this graph does it touch the graph in two places, and that's very important. And that's the definition of a function. You put an input in, you get an output. So in this case, and there's a thing called a one-to-one function, and this would be a one-to-one function. For every x input, you get one y output. So number 2, x equal, okay, this isn't even a function because you're going to have x is equal to the absolute value of y plus 2, and you're going to have two cases. You're going to have one where it's going to be x is equal to y plus 2, and the other case is going to be x is equal to the negative of y plus 2. So you're going to end up with two values for y, and that is not going to be a function. So this would not pass the vertical line test, and it's just simply not a function. Or maybe let me think about that for a second. Yeah, it wouldn't pass the vertical line test because I believe it's going to look something like that with a shift. So when you plug in 2, you know, remember, because you're going to get two values for y. Anyway, don't hold me to that. Okay, so the next guy says this. 10 is equal to, so I'm going to rewrite this as y is equal to -1 over y times x minus y plus 10. And then if I moved stuff around and I tried to break this x free, would I get a y squared? Let's see, there's a couple ways that we could do this to see here. Let's go ahead and factor out a y down here. So we have -1 over y times x minus 1 plus 10 is equal to y. And then I'm going to multiply everything by this value. Alright, so let's see here. If I multiplied everything by y, I multiply everything just by y, just to see what happens here. I get negative 1 over x minus 1 plus 10y is equal to y squared. So remember when I had asked in the beginning, I was like, well, am I going to get a y squared? And the reason I took the time to see if I would in fact get a y squared, and I don't have anything else that I would, well, this is 10y. Well, and then if I divide by that, I end up right back in the same place. I could factor it out. So let me just do some more math just to see what happens. I just want to make sure that this y squared doesn't cancel. And I've never done one of these per se in this manner, because generally when they ask you this question, it's usually really obvious. Like this one. Look at number 6. It says x equals y squared. Okay, well there is the y squared. So you know it's not a function. In this case, notice that it's buried down here. So when it's buried down here, what could happen is that this y could cancel out somewhere, and then it might look like it's not a function, but it is a function because somebody just took a function and multiplied the top and the bottom of it by y and then split it up in some manner to bury it in the function. So you'd have to do some algebra to figure it out. So what I'm going to do here is I am going to solve for y, and we'll see what happens. And I'm not going to show the math. I'm just going to do it, and then we'll look at the result at the end. And actually, while I'm looking at this thing, we can see it right here. So we have y squared is equal to, I'm sorry, that's not what I wanted to do. I wanted to put the equal sign on the other side. So this stuff is equal to y minus 10y. And then when I factor out a y, I'm still going to have y. And I'm going to end up dividing, yeah, so this is not a function. So there it is. Alright, the next one is a piecewise defined function. And basically what I want to see here is, are all of the values from negative infinity to positive infinity, are they accounted for? And is each of these a representation of a function of x in terms of, or a function of y in terms of x? If that makes sense. I think that's the right terminology. Okay, so we have, and actually we have a graph of this that we had done before, where we had 0 is 4, and then negative 1 greater than 0. So we had this, and then we had the line negative 2x minus 1. So then this would get filled, oh wait. Okay, so right here, just looking at this, and this isn't the same graph, this is different. What I notice here is that you see how this line is equal to 0, and this line is equal to 0. So if I plugged x is 0, I would get two values. I would get one that says 4 and the other one that says negative 1 for y, and that is unacceptable. So I'm going to say that no, this one, not a function. And this function does not pass the vertical line test, because if I take my finger and I run it across here, when I get to this point, this is going to do something like that. When I get to this point, I'm going to end up with two values, this one and this one. Alright, so this one, obviously it has a y squared in it, so we're going to discount that one. And then I wonder, plus or minus. That guy's got y squared, so it's not a function. And this guy is a function of x. Or you input x and you're going to get y, and no matter what, it is going to be a function. And it sucks because I wanted to show one that wasn't a one-to-one function. So let's just look at this one. So y equals x squared. And we'll just go ahead and graph that. So negative 2, we're at 4, and 2, we're at 4. So we got something like this. So it passes the vertical line test. Oh, that's what it is. That's what it is. So we have this take your finger and run it across the piece of paper, and you get for every x value, you get a y value, right? But notice that for y values, now we flip the paper and we take our finger and we run it this way. And this is the one that tells us if it's a one-to-one function. So I'm going to move my finger up and down. And what I'm looking for is this. When my finger crosses across here, I get two values. See them? It's still a function. It's still a function, but it's not a one-to-one function because of that. And I'll go ahead and show the other part of it in the same respect. Notice that the graph of x cubed, if I take my finger, I know that's a terrible finger, and we move it up and down, the y values, you only get 1. So for 3 we go over here, for 4 we go over here, and this is called a one-to-one function. So for every x value, it equals exactly one y value. And that goes along with if you're given a table of values and they ask you something like this, they'll say, so say these are my x values and these are my f of x values. So when I input -1, I get 1. When I input -2, I get 1. When I input -3, I get 1. When I input -4, I get 1. And when I put -5, I get 1. Now, is this a function? Well, what this means is that for each one of these values, it's going to be 1. And we'll just say that, it's going to keep on going on and on forever. Or whatever. Let's just call it that. So, it passes the vertical line test because for every x value, you get one y value. See? And it doesn't pass the horizontal, or the horizontal line test, the vertical line test. I get my terminology mixed up. Okay, so if I run my finger across this way, notice that for when I get to here, I got 1, y equals 1, but it's always going to equal 1. And for all these values, I end up with multiple values. So it is a function. It's just not a one-to-one function. Let's look at another variation. So if I had x values and I had f of x values, and we'll say that we have -2 goes to 4, and 3 goes to 2, and -2 goes to 1. So when I go over here and graph this, -2 goes to 4, at 3 it's at 2, at -2 it's at 1. Wait a minute. That's the issue right here. I end up with two values. So this is not a function. And this one is a function. Alright, so hopefully that didn't confuse you too much, but anyway. So it has to pass the horizontal line test to be a function, and it has to pass the vertical line test to be a one-to-one function. I think I said that backwards. I'm batting 1,000 today. Vertical line test. When I move my finger across this way. When I move my finger across this way, we end up with a horizontal line test. So horizontal line test, one-to-one function. Vertical line test, function.